Hello everybody. Today we are talking about fetching weather data from an API, pulling it into a data frame, and then doing some simple aggregation on that data frame, and then plotting the results onto a Folium map. Okay, so we can get our weather data from this source. There's several sources, weather.com. WeatherBit is what I'm using right here. All you have to do is create an account, go to sign up, enter some basic information like your email, username, password. That's pretty much it. You get your weather data straight from this API, and it's good. They don't give me tons and tons. They want for free. They want to make money. So if you pay for a subscription, you can get access to all kinds of stuff. In this case, I just signed up for a free account, so you have a limited number of API calls. But just to illustrate the purpose for what we're doing today, that's perfectly fine. If you want to do this in a professional environment or do some kind of heavy duty analytics on weather data, then you would definitely have to sign up for a paid account. In this case, we're just using a free account. So we'll pull in the API data. When you sign up, you'll get your API key. I removed mine here. I can't share. I'm sorry, I can't share my API key with everybody in this public domain right here, but you'll get your own. You pop it in here. This is a base URL. Keep everything the same. All you'd have to do is put in your specific API, whatever they give you, and that's it. Okay, I create a function. So this will go ahead and make a call to the base URL. That's what we just looked at, and you should receive a response code of 200. That's a success code. Anything other than 200, there's an issue with your credentials logging in. Perhaps you've used too much data and they're rejecting your request to fetch a new set of data. So that's going to be denied. But typically, if you've done everything correct, you're going to get a response code 200. And then as long as you get that, you'll get a JSON string. So we're going to pull in the JSON string, moving down just a little bit here, creating some sort of like fictitious zip codes all around New York City. I know the zip codes all around New York, they start with 10001 and end with about 10100. But in this case, I didn't have the actual zip codes, and basically no weather data that I've seen is going to give you the zip code. They always give you latitude and longitude coordinates, and you have to derive the zip code from that longitude and latitude coordinate. So I'm breaking this into zip codes so we can see the neighborhoods of New York City. You can certainly plot by longitude, latitude coordinates. That's very easy to do. I have a couple videos coming out about that specific topic very soon. So that's doable, but it's going to look a little bit weird when you're looking at neighborhoods. If you want longitude, latitude coordinates, there's a lot of use cases for that. I don't think this is the appropriate time or place for that type of thing. So I'm artificially or literally looping through some artificial zip codes. Not every single one is going to be covered in the city of Manhattan. So we're going to have a couple errors, but we just ignore those errors as we run through. Okay, we'll get all the zip codes from 01 up to 100, and we're going to go ahead and make a request to weather.com, get the data, and then start fetching the data for each of these neighborhoods in Manhattan. Let me scroll down just a little bit. Here's what the results will look like. Now, I ran this previously because I can't expose my API code, right? But I ran this, replace the API code just with that string, literally this thing right here. So I'm not running this in real time. I just ran this prior to recording the video, but I'm not running this now. But anyways, you put in your API code, you'll get these results right here. Clouds, dew point, max GHI. I'm not even sure what some of these things are, to tell you the truth, but I'm looking for precipitation. I want to measure how much precipitation occurred in each neighborhood in Manhattan. Okay, and I'm going to take the results and then sum that up right here by postal code. So I've organized everything by postal code. Okay, gotten the postal code from right here. So again, that's derived. That doesn't come specifically from the data. You have to create that yourself. So you get the postal code around Manhattan. You have wind speed, wind gust speed, I guess. So a few things like that. And that's fine. So we're grouping by precipitation. That's what I want to do. I want to plot the intensity of rain around Manhattan. So by zip code, by postal code, zip code, same thing. We have the precipitation. That's what this does right here, this aggregation of this data frame, grouping by postal code and summing precipitation. Okay, and we come down here, we have to pull in a SHAP file. This is going to show us geographical information. I'm going to share all this data with you below, all the data sources. So you already saw where the API comes from. There's a SHAP file that you have to download from the web. This is basically geometrical data, and they have zip codes as well. So this is very useful. You actually need this in this case. It's very useful for showing you zip codes, geographical data, latitude, longitude coordinates, and so on and so forth, all across the United States. Okay, so we're going to merge the SHAP file on this field right here, ZCTA. This has a kind of a weird code, but I Googled this. That's basically a zip code, and this is also a postal code right here. So we're zipping these, we're merging these two into one merged data frame, and then we can feed that into our Folium map. So there's a few different features. We have merge data filtered, and then the data is the same, right? The columns are the postcode, zip code, and the which is the same thing, and then the precipitation, right? And then you have a generic color feature here. You can change this to whatever you want. If you go on Folium, you'll see all the documentation there. Scroll down a little bit, and you will see the Folium map of precipitation across Manhattan, with the darker colors representing more precipitation. So basically, a big storm passed through southern Manhattan, overflowed a little bit into the financial district. It goes into, what was this, Greenwich Village a little bit, Soho, Lower East Side, things like that. Midtown got a little bit of a drizzle here, and then up around Central Park and up into the Upper East Side, Harlem. They got much less precipitation, right? The lighter colors represent lower precipitation amounts, and darker colors represent more. So there's a storm that passed through the city of Manhattan, with the concentration being on the lower tip, and the fringe was in the upper northwest area. So this is pretty easy and pretty cool to do with Folium maps. What are Folium maps useful for? There's all kinds of applications. Very easy to use, set up, very interactive, customizable. Support for GeoJSON, that's what we're seeing here, geographical JSON, JavaScript object notation, that's what it stands for. JSON looks kind of funny to a human being reading it, but it packs in data very efficiently, very compactly, and you can expand that and explode that quite easily for a human being to read. I'm going to have a video on how to do that coming out very soon, so look for that. Integration with Jupyter Notebooks, everything right here that you're seeing is running in a Jupyter Notebook. Efficiency, integration with other libraries, pandas, geospatial libraries, etc., etc. Lightweight and open source, so it's totally free. When I was growing up, my friends and I had the saying, if it's free, it's for me. And that's true. I like that. I like things that are free. So that's it. That's how to fetch weather data using an API call to, we're looking at weatherbit.com, but it could be any weather source. Weather.com is pretty huge. There's multiple sources you can look up on the internet. I put all the source data down here where to find that SHAP file. And yeah, Shapely data is right here. So I'm going to save this file and post it with the video. You're going to have this HTML file that you can download. And just open the file, simply open it, and you're going to see exactly what I see here. So I'm sharing all the source code with you so you can copy and paste this, see how everything works on your machine, and then customize it for your specific use, right? Like if you're applying something else, the plots are basically all done. This is pretty dynamic, pretty generic. I'm just showing one use case here, but there's so many applications for doing plots of almost anything you can think of, and doing all kinds of analytics with weather to, what's happened in the past. It's very easy to understand, and even using that data to make predictions into the future. That's pretty easy to do. So there's so many different use cases here. The sky's the limit. The only limitation is your own imagination. Okay, so hopefully you learned something new today. Thanks for your time. Have a great day. Bye.